ఒకవేళ చాటింగ్ చూసుకోవాలనుకున్నాడు ఇది ఒకసారి ఇలా అనండి, ఇక్కడ చాటింగ్ కనపడుతుంది, ఒకసారి ఇక్కడ ఇలా అనండి, ఇక్కడ చాటింగ్. ఓకేనా? ఒకసారి అడిగిన పిల్లలు ఈజ్ ఇట్ ఆడిబుల్ అండి?
మా స్టూడెంట్స్, ఈజ్ ఇట్ ఆడిబుల్? యా.
సో ఇది కావాలంటే ఇక్కడ చూడాలి, ఈ చాటింగ్ కావాలంటే ఇక్కడ చూడాలి. మెయిన్ దీని మీద చూసుకుంటూ ఉండండి, ఎక్కువ క్రౌడ్ వస్తుంది. రైట్, క్యారీ.
ఓకే.
7th shift to 7th shift to AP EAMCET 2022.
Ravi, we are discussing question paper AP EAMCET. AP EAMCET shift 2. That is the 7th phase. 7th phase, shift 2. Okay. For exclusively online students, you can have the paper. You have the paper in link description. You can see the link in description. Okay. Akila, Ashwit, Raghava, everyone, you can see the question paper which is there in the link. You can see in description. Okay. Right, see, this is the shift to 7th phase. We are discussing, you can see the chemistry paper. The question number 1, that is 121th question, 121st question. The work functions for the metals are given. How many of the above metals do not eject the electron when they are made to strike with radiation of wavelength? Radiation of wavelength. Okay. So the wavelength of the radiation is given. This is the 121st question. 121st question. The wavelength of the radiation is given. He is asking how many of the metals cannot eject the electrons. That is photoelectric effect. Okay. If the photoelectric effect, if you are going to find what is that, the energy is called threshold energy. If the energy of the radiation is less than threshold energy, in such a case we are not going to find a photoelectric effect. That means no ejection of electron. No ejection of electron means we are not going to find photoelectric effect. Okay. If energy irradiated is greater than or equal to threshold energy, in such a case we are going to find ejection of electron. Ejection of electron. The threshold energy is nothing but work function of a given metal. Work function of a given metal. So in the question we have wavelength, we are going to find the energy of the radiation. That energy of the radiation you need to find in the electron volts. So we have different metals, that is lithium, and the other one is magnesium, copper, silver, potassium, and finally sodium. These are the metals we have. Their work function E naughts are given 2.42 and 3.7, 4.8, and this is 2.25, and for potassium is copper is 4.3, silver is 4.8, 4.8, 4.3, this is 2.25, this is 2.3. We have the 6 metals, their work functions are given. Work function means simply we can say threshold energy. So now the radiation energy we need to calculate. So what is the formula of radiation? While we have lambda, hc by lambda, E equal to hc by lambda. Okay, but we need to convert into electron volts. What is the value of H? H value is 6.625 into 10 power minus 34 joules second. C is light of the velocity of the light is C 3 into 10 power 8. Lambda is given 400 nanometers. Nanometers means 1 nanometer equal to 10 power. Yeah, students, this paper is useful for upcoming exams because the most of the pattern of the paper is similar that of TS EAMCET also. Okay. Right? Now see. So this is nanometers means 1 nanometer equal to 10 power minus 9 meters. Okay. So if you simplify this, you can get E equal to 6.625 into 10 power minus 34, 10 power minus 9, you can write 10 power minus 7. The 10 power minus 7 into 10 power 8 means 10 power 15, you can write. That is 3 into 4 into 10 power minus 34 into 10 power 15, you can write. This is the value. Okay. And now we need to convert into electron volts. Remember the value we are getting in joules. 1 joule equal to how many electron volts? Or 1 electron volt equal to how many joules? That is 1 electron volt equal to the value 1.602 into 10 power minus 19 joules. Then 1 joule equal to 1 by 1.602 into 10 power 19 electron volts. Therefore, the energy of the radiation equal to 6.625 into 3 by 4 into 1.602 into 10 power minus 34 plus 15 equal to how much? 10 power minus 19. This is 10 power minus 19 into 10 power 19 electron volts. Now you can simplify. This will cancel. You can simplify. 1.6 means 4 means you can get. This is 6.4. This is almost 6.4 means you can get 3 into almost you can get energy value 3 point something, right? 3.2 electron volts you can get. That means the work function which have energy is less than 3.2 electron volts, that work function can give photoelectric effect. The energy that are the work function of the metals which have more than the energy, that kind of metals are not going to give photoelectric effect. So the energy radiation energy is, we have 3.2 electron volts. The elements which have less than 3.2 electron volts, they can provide photoelectric effect. So which can provide photoelectric effect? Lithium can provide because energy is less than 3.2. Even potassium can provide less than 3.2. Even sodium can provide less than 3.2. Whereas magnesium, copper, silver, they don't have energy as similar that of 3.2, less than 3.2. Their work function is greater than 3.2 electron volts. So magnesium, copper, silver cannot provide photoelectric effect. Means these metals are not going to eject the electron. So how many metals are not going to eject the electron? How many we have? 3. How many metal atoms are going to eject the electron? That is also 3. Got it? So first we are finding the energy of the radiation. What we are finding? Energy of the radiation. So for that, what is the formula we are using? E equal to hc by lambda. Okay. That E equal to hc by lambda means E value h equal to, we are substituting. That is 6.625 into 10 power minus 34. C equal to 3 into 10 power 8 by 400 into 10 power minus 9. So on simplifying, you are getting the value in joules. That joules we are converting into electron volts. You can remember 1 electron volt equal to 1.60, 2 into 10 power minus 19 cool. What is that? Joules. Okay, 1 electron volt equal to 1 joule equal to 1 by 1.602 into 10 power 19 electron volts. So by multiplying you are getting the energy of the radiation. The energy of the radiation on simplification you can get 3.2 electron volts. If E is greater than E naught, then only we are going to find photoelectric effect. If E is less than E naught, that is work function, in such a case there is no photoelectric effect. That means there is no, what is that? Ejection of electron from the metal surface. Ejection of electrons from the metal surface. So that is the reason 3 metals have energy or work function is greater than the energy of radiation. These 3 metals cannot provide any photoelectric effect, means no ejection of electrons. Whereas lithium, potassium, sodium, these are the 3 metals can have photoelectric effect, means can exhibit photoelectric effect because their work function is less than the energy radiated. Okay, so 3 metals cannot provide photoelectric effect. So answer 3. Then the next one is question number 122, guys. Okay. Question number 122. C. The work function of metal is given 6.3 electron volts, that is E naught. The wavelength of the incident radiation required to just eject the electron from its surface. He is asking wavelength, the same thing. What is the formula? E equal to h nu. Formula E equal to hc by lambda. hc by lambda. This is the formula. Energy is given 6.3 electron volts. Just convert into joules. 1 electron volt equal to, we gave the formula. What is the value? 1.602 into 10 power minus 19 joules. Okay. H equal to Planck's constant value 6.625 into 10 power minus 34. C, that is velocity of the light 3 into 10 power 8 by lambda. Now you can simplify, you are going to get the answer directly. That you can get on simplification exactly lambda equal to 197 into 10 power minus 9 meters you can get. The 10 power minus 9 meters is nothing but nanometers. So you can write lambda equal to 197 nanometers. Okay. Okay, students. Yeah, coming for the 123rd question. In which of the following elements are correctly arranged in the order of decreasing order of their second ionization enthalpy? He is asking second ionization enthalpy. That is 123rd question. You can see. If you need to answer this kind of questions, how we are going to do? First you need to find the general increasing and decreasing order of ionization enthalpies of elements in groups and periods. In groups and periods. You can see, Nana, how do we write? If you are going to take in groups, how does the ionization enthalpy? From top to bottom, there is a increasing in atomic size. As the increasing in atomic size, the energy required for the removal of electron is decreases. So, the general ionization energy in groups from top to bottom, what will happen? Decreases. Ionization energy decreases. Whereas in the periods, what will happen? The generally ionization enthalpy increases. Ionization enthalpy increases from left hand side to right hand side. This is the general order. But we have somewhat effects called penetration power, off-field electronic configurations. Due to these reasons, there is no regular trend of ionization enthalpy in the case of periods. For example, let me take second period elements. The second period elements are lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and finally neon we have. These are the second period elements. So we can expect the ionization enthalpies: lithium, beryllium less than, boron less than, carbon less than, nitrogen less than, oxygen less than, fluorine less than, neon. We can expect like this because as we are coming from left hand side to right hand side, there is a regular decreasing in the atomic size, so that the ionization enthalpy can be increased within regular trend, which is expected, okay, which is obviously incorrect. But the original order of ionization enthalpy, lithium less than beryllium, but beryllium must greater than the boron less than carbon is less than nitrogen, but nitrogen is greater than oxygen and less than fluorine. We are going to write like this. Fluorine is less than neon. So why we are writing like this? Why we are going to find irregular trend in the ionization enthalpy of these elements? The reason behind it, while we are going to take beryllium electronic configuration, we are going to write 2s2. While we are going to write the boron electronic configuration, we are going to write 2s2 2p1. Means here we are removing the electron from s subcell, but here we are removing the electron from p subcell. The penetration power of s subcell is more when compared to the p subcell. So that is the reason what will happen. The beryllium can have more ionization enthalpy rather than the boron. So that is the reason you can write under the penetration power or penetration effect, beryllium can exhibit more ionization enthalpy. While compare nitrogen and oxygen, what will happen? Here the nitrogen electronic configuration we are going to write 2s2 2p3, whereas oxygen electronic configuration we are writing 2s2 2p4. That means this 2s2 2p3 means this is containing off-field electronic configuration as per the Hund's rule. So that means off-field electronic configurations are more stable due to the translational energy is more. Full-field electronic configurations electronic configuration is also more stable under the influence of low spin. Full-field electronic configuration is more stable under the low spin because the resulting spin equal to 0. The off-field electronic configurations has also more stable due to the translational energy is more. Okay, so under these two effects, off-field and full-field are more stable electronic configuration. As it is more stable electronic configuration, it is quite difficult to remove electron from the 2s2 2p3. So that is the reason nitrogen can have more ionization enthalpy. Now he is asking second ionization enthalpy of these elements. Now you can see, Nana, what are the elements we have? Carbon, nitrogen, oxygen and fluorine. See, simple logic. If he is asking ionization enthalpy 1, directly you can take this particular order for IE1. If he is asking IE2 or IE3, you just minimize the atomic number 1 unit less than the given atom. Lesser than the given atom. That means if I need to find IE2 of these elements, I need to write one element before to it. So one element before to it means you can write before it carbon, you can write boron. That means IE1 of boron equal to IE2 of carbon. IE1 of boron becomes IE2 of carbon. Okay. And now nitrogen becomes carbon, oxygen becomes nitrogen, fluorine becomes oxygen. As we gave the order already, that is boron less than carbon, carbon less than nitrogen, nitrogen is greater than oxygen. Now let me decode the IE2 of this is decoding. Nitrogen is nothing but oxygen. So oxygen greater than the next oxygen. Oxygen means fluorine greater than next carbon. Carbon is nothing but nitrogen greater than boron. This is the correct order of IE2 of oxygen, fluorine and nitrogen and carbon. This is boron is nothing but carbon. You can go with carbon. Oxygen greater than, fluorine greater than, nitrogen greater than carbon. Okay, na? Right. I told you many times, the similar questions can be repeated in many competitive examinations. AP questions కూడా యూజ్ అవుతాయి అమ్మా. మనకి 40 క్వశ్చన్స్ మనం నేర్చుకుంటే, ఎస్పెషల్లీ TS EAMCET రాసేవాళ్ళు 40 క్వశ్చన్స్లో అట్లీస్ట్ ఒక 30-40% క్వశ్చన్స్ అయినా రిపీటెడ్ మోడల్సే క్వశ్చన్స్ అడుగుతాడు. So this paper is very useful to you. Okay. Right. Next question now. Identify the element which has highest second ionization enthalpy. The same thing. He is giving carbon, phosphorus, nitrogen and oxygen. Next question. Question number 124. Question number 124. He is asking, identify the element which has highest second ionization enthalpy. Highest second ionization enthalpy. Second ionization enthalpy. He is asking. Okay. The elements given that carbon, phosphorus, nitrogen and oxygen. As we discussed already, this one, these three are second period elements. But while coming for the phosphorus is third period element. Phosphorus is third period element. So write carbon, nitrogen, oxygen in one period, which are second period elements. While coming for the phosphorus is which period element? Obviously third period element. Okay. So now as we have the ionization enthalpy order, IE1 or IE2 or IE3, anything, if you need to compare with different periods of elements, the second period elements have more than the third period elements. Remember. That means when compared to the phosphorus, these three elements have more ionization enthalpy. Now he is asking IE2, means ionization enthalpy 2. So the ionization enthalpy of 2 means how we are going to write, as we discussed already. The carbon, nitrogen, oxygen, you can simply write the element before than this. So you can write carbon becomes boron, nitrogen becomes carbon, this is oxygen becomes, you can write as nitrogen. So the IE1 of boron is nothing but IE2 of carbon, IE1 of carbon is nothing but IE2 of nitrogen, IE1 of ionization enthalpy 1 of nitrogen is nothing but IE2 of oxygen. As we discussed already, there are ionization enthalpy order, boron less than, carbon less than nitrogen. That means the order of ionization enthalpy 2 is oxygen greater than, nitrogen greater than carbon. So among all these, which is more? Oxygen has the highest, then nitrogen, then carbon, and finally you can write phosphorus. Okay, write down. Next, the general formula of the compound formed when a metal of group 1 reacts with non-metal of group 16 is giving. Metal group 1 and non-metal group 16. That is question number 125. You can see. Question number 125. See guys, he is giving metal, that is group number 1, means alkali metals. Okay. And he is giving another thing is non-metal, that is group number 16. Group number 16. We need to find the valency. The valency of a metal equal to number of valence electrons. Number of valence electrons for metals. The valency of non-metal equal to formula number of, that is 8 minus number of valence electrons. 8 minus number of valence electrons. Okay. For group number 1, this is for metal 1, group number 1, the general outermost electronic configuration we are writing NS1. How many valence electrons it has? Only 1 electron. So the valency is 1 for first A group metals or group number 1. Whereas for 16th group outermost electronic configuration we are going to write NS to NP4. The total number of valence electrons are 2 plus 4, 6. So the valency equal to, what is the formula? 8 minus number of valence electrons 6 you can write. So 8 minus 6 means you can write 2. 8 minus 6 means you can write 2. The label of the metal is given M. The label of the metal is given M. The label of non-metal is given X. So as we have valency, the metal valency is 1, the X valency is 2. From a method called crisscross method. What is that? Crisscross method. If you need to write the molecular formula of any compound, you can use crisscross method. That means you need to cross multiply with respect to their valencies. You need to cross multiply with respect to their valencies so that you are going to find the formula of the compound. So how can we write M2X? This is the molecular formula. Okay. Good morning, Nana. Sravya, good morning, Ra. Right. Once again you needed the same question, right? See, this is the metal given, first year group metal. The non-metal labeled with X given that group number 16. If you need to write the compound molecular formula, how do we write? By using crisscross method, we need to cross multiply the valencies of the metals. Okay, metals and non-metals. Sai. Who asked this one? Sai Saket, see this. Okay. So now, we are going to find the valency. For metals valency formula, valency of metals equal to number of valence electrons. The valency of non-metals equal to 8 minus number of valence electrons. For first group, the general outermost electronic configuration, NS1. So the number of valence electrons are 1. So therefore you can write valency as 1. Whereas for 16th group elements like oxygen, sulfur, selenium, their general outermost electronic configuration is NS to NP4. The total number of valence electrons are 2 plus 4, 6. We are going to find the valency equal to 8 minus 6 equal to 2. As we have the metal valency 1, the non-metal X has the valency 2. By crisscross method, to find the molecular formula, we need to cross multiply. That means you can multiply with 2 with M and 1 with X, so that you can write M2X is the molecular formula. Okay. Right. Then coming for the next question, guys. Arrange the following species. Sorry. The general formula of the compound. It is over. The next one. Question number 126. Question number 126. You can see. Arrange the following species in the decreasing order of their bond orders. He is asking decreasing order of bond orders. Okay. One is given NO and the other one is given NO plus and other one is given NO minus. So if you need to find the bond order, you can find its number of electrons. As we described already, within the table you can remember or you can recollect. So that is total number of electrons and coming for the bond order. How do we find? For total number of electrons 14, because as you know that nitrogen is the molecule which contains total number of electrons 14. So you are going to write N triple bond N. N triple bond N. N triple bond N means for 14 electrons we have the bond order. Bond order is nothing but the number of bonds present between two atoms. Simple logic. So here N triple bond N means we have 3.0 bond order. If you decrease the number of electrons by 1 unit or increase the number of electrons by 1 more unit, the bond order can be decreased by 1 by 2 units, means 0.5 units can be decreased. That means if I am going to write 13 electrons, the bond order becomes 2.5. If I am going to write 12 electrons, the bond order becomes 2.0. For 11 it becomes 1.5. For 10 it becomes 1.0. For 9 it becomes 0.5. For 8 it becomes 0.0. In the same way, for 15 again decreases 2.5. For 16 you can write 2.0. For 17 you can write 1.5. For 18 you can write 1.0. For 19 you can write 0.5. For 20 you can write 0.0. Now the species we have, what is that? One is NO and the other one is NO plus and the other one is NO minus. We need to calculate total number of electrons. How do we calculate the total number of electrons? By addition of their atomic numbers. By addition of their atomic numbers. For nitrogen atomic number 7. For oxygen atomic number 8. 7 plus 8 equal to 15. Okay. For NO plus means 7 plus 8. You need to subtract, because plus means loss of electron, means you need to subtract 1. How much charge, positive charge is there? That much charge you need to subtract. So 7 plus 8, 15. 15 minus 1 equal to 14. Okay. And coming for NO minus, the number of electrons 7 plus 8 minus 1 means accepted or gained 1 electron. You can add 1. This equal to 16. Okay. For 14, what is the bond order? 3.0 bond order. For 15, what is the bond order? 2.5. For 16, what is the bond order? 2.0. So the bond order for NO plus is greater than NO minus. This is the correct bond order of the given species. Are you clear with this? Everyone? Okay. Then coming for 127th question. Question number 127. Question number 127. See, 20 ml of a gas A and 10 ml of gas B diffuses through a porous membrane separately in 1 minute. If the vapor density of B is X, then what is the vapor density of A? Vapor density of A. That means this is the question related with Graham's law of diffusion. What is that? Graham's law of diffusion. So, in Graham's law of diffusion, he is comparing rate of diffusion, Graham's law of diffusion, comparing the rate of diffusion with the vapor densities, As we have already the Graham's law, the rate of diffusion, the volume of the gas covered by the gas per unit time. The volume covered by the gas per unit time is nothing but rate of diffusion. So now the time is taken constant. The time is taken constant, so that you are going to write volume of the gas A by volume of the gas B is equal to root over vapor density of gas B by vapor density of gas A, you can write, because here comparing volume of the gas with the vapor density of the gas. So from that you can write VA by V equal to root over vapor density B by vapor density A. So volume of A is given now, that is 20 ml. Volume of B is given, that is 10 ml, equal to vapor density of B is given X. We need to find vapor density of A. This will cancel. On squaring both sides, you can write 4 equal to X by vapor density of A. Therefore, vapor density of A equal to, you can simply write X by 4. So that X by 4 is there in third option. You can go with third option. Are you clear with this? Yeah. Yes. Coming for the next question. Question number 128. That is, he is giving types of reactions. First one, combination. 128, you can see combination reaction. Combination reaction means the two elements joined together to give only one product is called combination, chemical combination. That kind of reaction we have for third option. So you can go with the third. Mg plus N2 gives rise to Mg3N2. Two elements are joined, forms only one compound. The second one, decomposition. Decomposition means a single compound dissociates into two or more products. Decomposition means a single compound decomposes into two or more products is called decomposition. So for the decomposition, we have fourth option, KClO3, decomposed into KCl plus O2. Okay, we have the question like this, you can see. 128. He is giving combination, denotes with A, chemical combination, B, decomposition, the C, disproportionation, and D, displacement. The options we have: 1, AgNO3 plus CaCl2 gives rise to AgCl plus calcium nitrate, CaNO3 twice. The second one, Cl2 gives rise to Cl minus and ClO3 minus. The third option, Mg plus N2 gives rise to Mg3N2. The fourth option, KClO3 gives rise to KCl plus O2. These are the options. As we described already, what is combination? Combination means two different elements joined together to give only one product. This is two different elements are joined together to give only one product, means combination is 3. Coming for the decomposition. Decomposition means a single reactant molecule can be decomposed to give two or more products. That single reactant is decomposing two or more products is the decomposition is 4. Then coming for Disproportionation. Disproportionation means which is redox reaction, in which a single element can involve into both oxidation and reduction. Here oxidation number of chlorine is 0, here -1, 3 to the 6 minus 1 means +5. The 0 to -1 decreases, the 0 to +5 increases. This is reduction, this is oxidation. The same element involves in both oxidation and reduction is called redox, in which same element is called disproportionation. So you can go with second option. And finally, displacement. Displacement means that elements, cations and anions can be displaced by one by another. Here you can see silver displaces calcium, calcium displaces silver. So you can go with the first option. So for A you can write the combination 3, for B you can write the combination 4, for C you can write the combination 2, for D you can write the combination 1. So 3, 4, 2, 1 is the correct one. Okay. That is fourth option. Good morning, Ra Venkat. Like, see the next question. See the next question. Question number 129. Question number 129. See here. If the total electricity required to deposit 1 mole of metal is equal to that of 10.7 amperes of current for 10 hours, the equivalent weight of the metal is. He is asking equivalent weight of the metal. So this is actually from Faraday's first law we are going to do this. From Faraday's first law we are going to do this. Okay. So what is the Faraday's law? Question number 129. You can see, guys. The Faraday's first law, the weight of substance deposited equal to MIT by NF. Otherwise you can write W equal to EIT by F, Faraday. Equivalent weight into current into time by Faraday. This is the formula. If the total electricity required to deposit 1 mole of metal, 1 mole of metal means the weight of substance equal to number of moles into gram molecular weight, because the formula number of moles equal to weight by molecular weight, then weight equal to number of moles into molecular weight. As per the given data, how many moles deposited? 1 mole deposited. So that you can write W equal to 1 into M molecular weight. So therefore W equal to its atomic weight or molecular weight only. So instead of W you can write M. This is equivalent weight. I equal to current. The current is given how many amperes? 10.7 amperes. The time T is given. How much time? 10 hours. You can simplify it, or you can take it in seconds. You can write. This is M equal to equivalent weight we don't know. I equal to 10.7. 1 hour equal to 60 minutes and 60 seconds. This is Faraday equal to 96,500 coulombs. This will cancel. Now you can simplify. 10.7 means into 6 means 6 7 is 42, 6 1 is 6. So M equal to E equal to M into 965 by, this is 6 7 is 42, 6 1 is 6. That is 64.2. and 6 6 into 6 we have, into 1 more 6 we have. Can you simplify? You can get almost 1 by 4. దీంతో simplify చేస్తే the equivalent weight you can get m by 4. m by 4. One by 4. Okay. Next one. Question number 130. Question number 130. You can see, which of the following correct statement? Identify the correct statement from the following. The first one is given, for adiabatic process delta U equal to W adiabatic. So from thermodynamics first law we can write delta U equal to plus or minus Q plus or minus W. In adiabatic process delta Q equal to what can we write? 0. So therefore delta U equal to plus or minus W adiabatic. Adiabatic. So the first statement is correct only. Work is path function. That is also correct statement, because work and energy like heat, these two are the only path functions. The remaining all are state functions only. Remaining all are state functions only. So this statement also correct. Volume is an extensive property. Obviously volume is extensive property because depends on amount of substance irrespective of the nature of substance. Irrespective of the nature of substance. So all the three statements are correct only. All the three statements are correct only. Next one. Question number 131. The standard molar enthalpy of vaporizations. 131 you can see. Standard molar enthalpy of vaporizations of A is A comma B comma C. Their standard enthalpy of vaporizations are given. Delta H naught. For A is 23.3. For B is 41. For C is 29. For C is 29. Now he is asking the correct order of dipole-dipole attractive forces. The dipole-dipole attractive forces. See, the enthalpy of vaporization is inversely proportional to, is directly proportional to boiling point. Is directly proportional to boiling point. If any molecule has more boiling point, that indicates the interactions are more. The interactions are more. That indicates is directly proportional to interactions. What kind of interactions? Dipole interactions. That is inversely proportional to volatility, means volatile nature. Volatile nature. Okay. Volatile nature means which has more boiling point, that has less volatile nature. Volatile nature means the ease of conversion of a liquid into its vapor state. A liquid into its vapor state. So that is the reason the enthalpy of vaporization which has more, the dipole-dipole interactions are more. That means dipole-dipole interactions for B greater than C greater than A. B greater than C greater than A. Okay, students. Pratap, we need to convert the hours in minutes into seconds. So that is the reason we are multiplying 6 into 6. Because 60 into 60 we took. Because the time is given in hours. Okay. Right. Then coming for the next question, students. Question number 132. Question number 132. See over there. The solubility product of MCl is given 1 into 10 power minus 10. What is the molar solubility of M in NaCl? 0.1 molar NaCl solution at same temperature. Now you can see, guys, this is the MCl, which is sparingly soluble substance, can be irages into M plus and Cl minus. If S amount is soluble, the solubility of M plus is also S and Cl minus is also S. Okay, but which is taken in 0.1 molar NaCl aqueous solution, which is soluble substance, which can be ionized completely into Na plus and Cl minus. If the concentration of NaCl is given 0.1 molar, this concentration also 0.1 molar, this concentration also 0.1 molar. MCl is sparingly soluble substance, but this is a soluble substance. What kind of substance it is? Soluble substance. So now we are going to write the solubility product of MCl. How do we write? Concentration of M plus into concentration of Cl minus we can write. So the Ksp value is given, that is 1 into 10 power minus 10. The concentration of M plus is S. The concentration of Cl minus is common ion effect is there. So you can write S into 0.1 you can write. That means 10 power minus 1. 10 power minus 1. So that means you can write S is very, very, very less than 10 power minus 1. So you can neglect S value. Therefore, S into 10 power minus 1 equal to, you can write 10 power minus 10. So S equal to 10 power minus 9 molar. So the molar solubility of MCl in 0.1 molar NaCl is obviously 10 power minus 9. Okay. Then coming for the next question, 133rd. 133rd. See the 133rd question, students. The solubility products of these compounds are given. 133. Okay. The solubility products of nickel sulfide, zinc sulfide, cadmium sulfide, mercuric sulfide are given values 4.7 into 10 power minus 5. These are solubility products, Ksp. Okay. And he is taking 1.6 into 10 power minus 24. For cadmium sulfide given 8 into 10 power minus 27. And finally, mercuric sulfide is given 4 into 10 power minus 53. Now he is taking different solutions, nickel, zinc sulfide, cadmium sulfide, Hg plus 2. Okay. These are the cationic solution which is containing Ni plus 2, Zn plus 2, cadmium plus 2, and finally mercuric plus 2 solutions are there. Okay, solution containing these ions. Over these ions he is passing aqueous solution sulfide, hydrogen sulfide gas, and he is asking which ion can precipitate first and which ion cannot precipitate. That means which ion can precipitate last. Remember, the solubility of any substance is directly proportional to the solubility product. The solubility product. The ion which can have, or the compound which can have less solubility product, that can form precipitate easily. The ion which has less solubility product, that could not form, that could not form more solubility product, that could not form precipitate easily. The ease of precipitation is inversely proportional to the solubility product. Which can have more solubility product that could not form precipitate? Which can have more solubility product that could not form precipitate? Which can have less solubility product that can form precipitate easily? Among all these, which has the least solubility product? That is 10 power minus 53 range. So which can form precipitate? Ease of formation of precipitation is HGS greater than the next one, 10 power minus 27 range. Cadmium sulfide greater than, zinc sulfide greater than, and nickel sulfide, because the solubility of nickel sulfide is more, for mercuric sulfide is less. So which can form precipitate more readily? HGS. Which can form last? That is nickel sulfide. He is asking which is formed first and which is formed last. So Hg plus 2 form first and nickel sulfide form. That means nickel plus 2 forms at last. Okay. Based on that solubility product we are going to find which can form precipitate first and last. Okay. The next question. See the question. This is also match the following, 134th. We need to write match the following question. See Nana? Question number 134. Matching test. Match the following. Electron precise means sufficient number of electrons are present around the central atom. This is A. Electron precise. The B is given. What is B? What is B? Saline. What is C? Electron deficient. Electron deficient. These are actually hydrides. Deficient. And D is asking electron rich. Electron rich. You need to find the hydrides because hydrogen can react with different elements. They are going to form different hydrides. Some of the elemental hydrides can have the central atom possessed with exactly octet electronic configurations in which all the paired electrons are bond pair of electrons. The electron precise hydrides can formed by the 14th group elements. 14th group elements means carbon, silicon, germanium, tin. This kind of elements can form electron precise hydrides. Then saline hydrides are also called metal hydrides. What are these? Metal hydrides. If the hydrogen gas reacts with metals like first year group and second year group elements, that is going to form saline hydrides are metal hydrides. And coming for the third one, electron deficient. Electron deficient means the central atom does not possess octet electronic configuration. Maybe 2 or 4 electrons are shorter than the octet electronic configuration. So which elements can form this kind of hydrides? Group number 13, boron, aluminum, gallium, indium. Or second year group. Second year group means like beryllium. These kind of elements are going to form electron deficient hydrides. And electron rich hydrides. The central atom is going to possess octet electronic configuration if one or more number of electrons or paired electrons must be there, not involving in chemical bonding, not involving in chemical bonding. So which group elements are going to form this kind of hydrides? Obviously group 15, group 16 and group 17, because at least one lone pair should be there on the central atom. For example, you can take ammonia, the nitrogen contains one lone pair of electrons. If you take water that contains oxygen, contains 2 lone pair of electrons. If you take hydrogen fluoride that contains fluorine atom, 3 lone pair of electrons. Okay, so based on this you can write, this is, first one is given silicon hydride. That means electron precise, the same option. The second one is given H2O, as we described already. Oxygen contains 2 lone pair of electrons, electron rich, electron rich. The third one is given magnesium hydride. Magnesium hydride means metal hydride, which is called saline hydride. And while coming for the fourth option, that is B2H6, we are going to write BH3 twice actually. Boron is 13th group element in which doesn't possess octet electronic configuration. So which is electron deficient hydride. So for A you can write 1, for B you can write 3, for C you can write 4, for D you can write 2. So 1, 3, 4, 2 are the correct options. Okay guys? Right, then coming for the next question, students, you can see. Question number 135. Hydration enthalpy of which of the following ions is highest? Hydration enthalpy of which of the following ions is highest? That is 135. 135. Hydration enthalpy, if we need to find more. So the enthalpy of hydration of a given cation is inversely proportional to size of cation. The first thing, hydration means it need to form complex with water. What is enthalpy of hydration? As we described already in many classes. Mx is a salt which is going to added into the water. This is going to form a complex with x moles of water and releases certain amount of energy. The formation of complex with water means we are going to find a dative bond present between metal and H2O. H2O can be considered as ligand. So the formation of coordinate covalent bond is non-metallic character. For a given metal, the non-metallic character can be increased with the decrease in size and increased with the increasing in charge. Increased within the charge. So hydration enthalpy, whatever the amount of energy released, that is called hydration enthalpy. So the hydration enthalpy is depends on the ability of formation of dative bond with water. So that is the reason the dative bond formation inversely proportional to size of cation. So that means metal ion. So enthalpy of hydration is inversely proportional to the size of cation. And another thing, enthalpy of hydration is directly proportional to the charge of a given cation. Means metal ion. How much charge is there? That much efficient is there. The ions you have magnesium plus 2 and sodium plus, calcium plus 2 and potassium plus. As we described already. What is that? The hydration enthalpy is directly proportional to the charge. So magnesium plus 2 and calcium plus 2 has more when compared to the Na plus and K plus. So that is the reason enthalpy of hydration is inversely proportional to size. Magnesium plus 2 has small in size, so greater than. Calcium plus 2 somewhat more, greater than. Na plus greater than K plus. These two ions are not hydrolyzed because alkali metals which have large enough size, they are not going to hydrolyze. Hydrolyze means they are not able to form dative bond with water molecules. So which can hydrolyze easily and hydration enthalpy is more, that is for magnesium. Okay. Next one. Identify the correct statement from the following. Question number 136. Question number 136, you can see guys. Identify the correct statement from the following. You can see. Alkali metals are strong reducing agents. Alkali metals are strong reducing agents. That is correct because reducing agent strength depends on metallic character. So alkali metals are highest metallic character than any other elements in the periodic table. So first statement is correct. KO2 is diamagnetic oxide. In KO2 what we are going to write? O2 minus we are writing. What we are writing? O2 minus. How many number of electrons are there in O2 minus? The atomic number of oxygen is 8. 2 8 is 16. Minus 1 means 17 electrons. 17 electron system means odd number of electron system. The odd number of electron contains at least one unpaired electron which is going to exhibit paramagnetic nature. So second statement is incorrect. The given statement is diamagnetic, but the compound is paramagnetic in nature. While coming for the third one, lithium chloride exists as in the LiCl.2H2O, as we discussed already. If you add lithium chloride into the water, as the lithium plus is small in size, it is going to form complex with water, LiH2O plus, twice plus, and Cl minus we are getting. So it is going to bring dihydrated salt by the formation of dative bond with water. So the third statement is correct, second statement is incorrect, first statement is correct. So you can go with A and C. That is 136. Coming for 137 students. 137 is over. Coming for the 137. Aluminum chloride is acidified aqueous solution gives a complex ion X. The hybridization of the central atom in X is. The central atom in X is. See the 137th question. We are taking aluminum chloride, AlCl3. Acidified HCl, you can take acidic medium hydrochloric acid, HCl aqueous. Then what it is going to form? It is going to form AlCl 6 times minus 3 complex. What it can form? AlCl 6 minus 3 complex. The coordination number of aluminum is 6. The ligand Cl minus is the ligand. What kind of ligand? Weak field ligand. In case of weak field ligand for coordination number 6, the hybridization of the central metal atom is sp3d2. For strong field we can write d2sp3. For weak field we can write sp3d2. So you can write sp3d2 hybridization. Okay. Next one. Coming for the 138th question. Bond enthalpy of germanium is given. The bond enthalpy of silicon tin in kilojoules respectively. Okay. Given that the germanium bond enthalpies are given, that is 260 kilojoules. He is asking silicon and tin silicon question mark and tin question mark. Okay, see Nana, in 14th group elements, the bond enthalpy from top to bottom decreases. The bond enthalpy from top to bottom decreases. So that means the bond enthalpy of carbon greater than, silicon greater than, germanium greater than, tin greater than. This is the bond enthalpy order. So for germanium is given 260. This value must be greater than 260. So that we have 297. So for silicon you can write 297. For tin must be less. The 260 less than 260 means you can write 240. For silicon you can write 297. For tin you can write 240. That is there in third option. You can go with third option. Okay. The next question. 139. Identify the molecules which have sp hybridized carbon from the list given under. Okay. The molecules with sp hybridized carbon. The first one is given ethane nitrile. This is 139th question. Ethane nitrile means CH3C triple bond N. This is the first one. The second one, buta-1,3-diene. Buta-1,3-diene means CH2 double bond C, H single bond CH, double bond CH2. Third one, propan-1,2-diene. Propan-1,2-diene. This we can write. Fourth one, ethine means C triple bond CH. Fifth one, benzene. means you are going to write like this. So he's asking sp carbon. What is asking? Sp carbon. Sp carbon means around any atom you are going to find C triple bond C, means around any atom 0 pi bonds are there, that is sp3 carbon or sp3 atom. Around any atom 1 pi bond is there, that is sp2 hybridized atom. Around any atom if 2 pi bonds are there, that is sp hybridized carbon or any atom. So now you can see within this, around this nitrogen, around this carbon, we are finding 2 pi bonds. So that means this contains sp hybridization. Here only 1 pi bond, here also 1 pi bond, here also 1 pi bond, here also 1 pi bond. All the carbon centers are sp2, there is no sp center. Around this carbon 1 pi bond, around this carbon 1 pi bond, but this carbon around 2 pi bonds are there. This is a sp center, contains sp center. And around this carbon 2 pi bonds are there. This is also sp center. This is containing around only 1 pi bond. So that is the reason it is sp2 carbons. There are no sp and sp3 carbons. So sp carbon containing compounds, fourth one and third one and finally first one. So how many molecules are there with sp3 centers? Those are only 3 we have. So you can go with 1, 3 and 4. Okay students, coming for the 140th question. The decreasing order of acidic nature of the following compounds is. The decreasing order of acidic nature of following compounds is. 140th question. We have the benzene ring with C triple bond CH. C triple bond CH. The second option we have nitro group with C triple bond CH at para position. And we have amino group with para position C triple bond CH. Right, you can see, as we discussed already, the hydrogen which is directly binded to the triple bond carbon, that has acidic in nature. So this is acidic proton, this is acidic proton, this is also acidic proton. Now based on the nature of the group, we are going to find acidic strength. What is that? The minus I and minus M groups are going to increase the acidic strength. Plus I and plus M groups are going to decrease the acidic strength of a given compound. So in the first example, no groups are there. But in the second example, NO2 can act as minus M group. Whereas in the third example, the nitrogen contains lone pair of electrons which can act as plus M group. So plus M groups decreases, minus N and minus I groups are increases. So this is as per the statement, this is 1, this is 2, this is 3. Okay. So now the acidic strength minus I groups increases. Second statement is more than the first one. The third, the plus M group decreases the acidic strength. So the acidic strength order is 2 greater than 1 greater than 3. Okay. Then coming for 141st question. Next question, see 141. Question number 141. The density of sodium is given. The edge length of the unit cell is given. The effective atomic numbers of atoms of sodium per unit cell. He is asking effective atomic number. What is asking? Effective atomic number. Okay, see. The density of a given unit cell equal to formula, the effective atomic number into atomic mass by A cube, means volume into Avogadro number. This is the formula. The density of sodium is given 0.613. The effective atomic number we don't know. The gram molecular weight of sodium is 23 grams by A cube. A cube means unit cell edge length 5 angstroms. 5 angstroms means 5 into 5 into 5. 1 angstrom equal to, we need to convert into centimeters. 1 angstrom equal to how many centimeters? 10 power minus 10 centimeters. So 10 power minus 10 whole cube. Avogadro number means 6 into 10 power 23. If you simplify the value, you can get Z for this molecule exactly 2. 2 vastadam. Okay na? Right, next one. One 43. 3.1 grams of compound X is dissolved in 19.5 grams of compound Y. The ratio of mole fractions of X and Y. Question number 143. Question number 142. See. A grams silver crystallizes in FCC lattice. What is the total number of tetrahedral weights present in 540 grams of silver metal? Are seen na? Number of octahedral weights, if you need to find n number, number of tetrahedral weights equal to 2n number. Okay. So we need to find number of moles of silver in the given weight. Given weight 540, silver atomic weight is 108. If you simplify, how much you can get? 108 3 sorry. 3 1 3. Simplify cheyandi amma enta vastunda? 540 by 108. You can get 4. Antena? You can get how many moles? 5 vastunda? 5 8 is 40, yes. This is 5 moles. So number of moles, number of tetrahedral weights equal to em cheppam 2 into 5 moles. So 2 5s are 10 moles of tetrahedral weights. Ten moles means 10 into Avogadro number. That is incorrect. Okay, next one. Question number 143. Question number 143. 3.1 grams of X is dissolved in 19.5 grams of Y. the ratio of mole fractions of X and Y. Mole fractions ratio is directly proportional to what is that number of moles. Antena 143 chondama. 143. The mole fraction of X Yx by mole fraction of Y is equal to number of moles of X by number of moles of Y. Number of moles equal to given weight by molecular weight. ఏమైందమ్మా given weight ఎంత ఇచ్చాడు 3.1 by 6.2 into given weight of Y 19.5 by 78. Simplify చేయండి రా. This is 62, not 6.2. This is 20. 9.8 అంటే ఎంత అవుతుందమ్మా 78. This you can get 4. 4 5 is 20. Yx by Yy equal to 1 by 5. Next one. Next question, direct question. For which of the following liquid mixture delta H equal to 0, delta V mixture equal to 0, the delta H and delta V mixture must be 0 for ideal solutions. Question number 144. Among these, which is the ideal solution? Ethyl chloride and ethyl bromide can form ideal solution. You can go with first option directly. Next 145. The standard Gibbs free energy for the following reaction. He is asking K value given. Okay. So coming for the 145th question, students, he is asking delta G naught. Delta G naught equal to minus 2.303 RT log Kc. This is the formula. The delta G naught is given in kilojoules. So you can write minus 2.303, 8.314 in kilojoules 10 power minus 3. Standard Gibbs free energy means temperature you can take 25 degrees centigrade 298. The Kc value is given. Ten power 12 log 10 power 12 log 10 power 12. 12 log 10 means you can multiply with 12. That is minus 2.303 into 8.314 into 298 into 12 into 10 power minus 3 joules. If you simplify, you can get minus 68.47 into 10 cube joules you can get. The answer is minus 68.47 kilojoules. This is the answer. Okay. The next question. One 46. 146. What is the concentration in mole rate inverse of the product after 20 seconds in the following reaction? Following reaction is given. A gives rise to 3B, rate equal to given K into concentration of A power 0, means this is zero order reaction. What kind of reaction it is? Zero order reaction. He is asking the concentration of product after 20 seconds. So what is the formula for zero order reaction? K equal to A naught minus A by T. A naught minus A by T. So A naught is given 0.1, A is given 0.1 minus X, the T is given 20 seconds. Okay. So first find the rate. R equal to change in concentration per unit time. So change in concentration how much? 0.1 minus 0.05. 0.05. Then by time t, that is 15 seconds. Then how do we write R equal to rate equal to 0.05 by 15, means 5 into 10 power minus 2 by 15. That you can write 1 by 3 into 10 power minus 2. 1 by 3 into 10 power minus 2. For zero order reaction, rate equal to rate constant. Rate equal to rate constant. So rate constant you can write 1 by 3 into 10 power minus 2. A naught initial concentration is 0.1. You can write 0.1 minus 0.1 minus X. The time is given 20 seconds. Okay, no? This you can write 0.1, then X equal to X is nothing but concentration of B. That is 20 into 1 by 3 into 10 power minus 2. That you can get 6.6 into 6 into array 3 6 jara 6.6 into 10 power minus 2. This is X. Okay. But concentration of B equal to 3B we wrote, right? So 3 times of X. So therefore 3 into X you can write. That is 3 into 6.6 into 10 power minus 2. ఎంత వస్తుందమ్మా 19.8 వస్తుంది అంతేనా? సో దట్ ఈజ్ 1.98 into 10 power minus 1. Okay. Concentration of B is nothing but 3x. ఎందుకంటే initial concentration we are going to write A. This is 0. After time t, this becomes A minus x, but this is 3x. So concentration at 20 seconds becomes 3 into x. We found only x. Okay. Right one. Next one. Freundlich adsorption isotherm fails in which the following conditions: high temperature, low temperature, irrespective of the temperature, because we are Freundlich isotherms, we are taking temperature constant, irrespective of the temperature. We are going to concentrate with pressure. Freundlich adsorption isotherm is not applicable under high pressures. In last class we discussed the same question paper, right? So at high pressure it is not applicable, at moderate or low pressure it is applicable. So you can go with the third option. Coming for the 148. The number of positively and negatively charged souls respectively in the following This is direct question. You can take titanium oxide, metal oxides are negative soles. So titanium oxide is a positive sole example. Blood is a positive sole. Cadmium sulfide, negative sole. Copper, metal soles are negative soles. Copper, negative sole. Silver, negative sole. Clay is also negative sole. Silicon dioxide, metal oxide sole positive. Fe2O3 also positive sole. So 4 positive soles and 4 negative soles. Metal soles and metal sulfide soles are negative soles. Remember, metal oxide soles are positive soles. All right, next one. Arrange the following oxides in correct order of their acidic character. N2O3 non-metal oxide, P2O3 non-metal oxide, N2O5 non-metal oxide, AS2O3 non-metal oxide. The 15th group metal oxides are more acidic than 13th group metal oxide. All those are 15th group metals only, 15th group non-metals only. As we are coming from, you can write like this. Yes, wait. Question number 149, you can see, guys. The nitrogen N2O3, P2O3 trioxides are given, N2O5 and AS2O3 we have, AS2O3. N2O3 given 1, P2O3 given 2, N2O5 given 3, AS2O3 given 4. Here oxidation number of nitrogen plus 3, here oxidation number plus 3, here oxidation number plus 3, here oxidation number plus 5. The acidic nature of any element is directly proportional to its oxidation number, because acidic nature is directly proportional to non-metallic character, non-metallic character directly proportional to oxidation number. So among all these, which is more acidic? N2O5. So you can go with 3. While I am coming from nitrogen to phosphorus, that means down the group, non-metallic character decreases. What will be decreased? Non-metallic character decreases. Down the group, non-metallic character decreases. So that is the reason N2O3 more acidic, than P2O3 is more acidic, than arsenic trioxide 4. So the order is 3 greater than 1 greater than 2 greater than 4. Okay. Then coming for the 150th question. Which of the following represents correct order of oxidizing power of halogens with water? Oxidizing power of halogens with water means you can take the hydration enthalpy. Hydration enthalpy, as we discussed already, as the size increases, hydration enthalpy decreases. Got it? So that is the reason from fluorine to iodine, oxidizing power decreases due to the decrease in hydration enthalpy as the atomic size increases. The remaining 10 more questions we are going to discuss in our next class. For online students who are attended in YouTube live class, you guys, you can collect the more information there in last minute preparation, which is there in Roots app. Okay. You can collect more information how to prepare final exam within the less span of time, and you can see that questions, the discussions of question papers in that last minute program or last minute preparation, you can collect over there. The fees particulars only 500. With the 500 spending, you can collect more information. Okay guys, thank you. Wish you all the best.